Around 1991, Marshall released a couple of different pedals in black boxes, one of those being the Marshall Bluesbreaker. Now, the pedals apparently didn't sell too awful well because they discontinued them a little while after. And about 2006, John Mayer started using this Marshall Bluesbreaker, and the pedal got wildly popular again. Now, it should be noted that about 10 years after they initially created the Marshall Bluesbreaker pedal, that they came out with, I think it was called the Bluesbreaker 2. It was in a silver box. Not quite the same circuit, didn't sound the same. So let's go to about 2003 or so. Analog Man creates the King of Tone. Now, the King of Tone was based around the topology of the Bluesbreaker, but was radically changed to sound completely different and have more gain and some other things. And he put two of these circuits together. Of course, that was incredibly popular as well. And later on, he created the Prince of Tone, I think was just single one of those versions. But today, I thought, let's take a look at what makes the Bluesbreaker so great. So here on this breadboard here, I have the Bluesbreaker circuit. As you may not be able to see, but that's really what it is here. So we have the initial gain stage, it's just a non-inverting gain stage, into a inverting gain stage, into basically simple tone control, and then out. So let's take a little bit of a look at it and look at some frequencies and really kind of do some of the fun, nerdy stuff with this particular circuit. First of all, my clean tone going through the bravado. Now, on this particular breadboard here, I have over here is the gain control. This is going to be the tone control, and this is the volume control. So you know what I'm turning, that's what's going on here. Now, with the way this is set up, this gain control is going to change not only the gain in the first section, the non-inverting op-amp stage, but also going to change the gain in the second section, the inverting op-amp stage. So it's kind of doing both. So let's start with it all the way down. It's going to be really, really clean. Not a whole lot going on there. Some people like to modify these in different ways to give it a little bit more added gain as well. In fact, this is one of the things the King of Tone did, is put a little bit more added gain whenever it's down all the way. Let's turn the gain up. Now, of course, one of the things that people love to use this particular circuit for is kind of like a warmer, slightly dirty boost. Let's start with the gain around noon or so, give or take. Turn up the volume just a little bit. You can add a little sparkle to it. Actually made a little bit more. Now the fun part, what happens with each part of the circuit? Let's start changing some parts out and just kind of see what it's doing here. All right, the input capacitor. Normally this is a 0.01 microfarad. Let's see what happens when we make the cap a lot bigger. Sometimes this does a lot depending on the circuit. Sometimes it doesn't do a whole lot. Let's see. First of all, we're going to start off in the stock setting. Then I'll turn this little switch on here, and that will basically put the larger capacitor in the signal path. Not a whole lot of difference there. Let's go on to the next part. We have several different things we can do here. First of all, we have the potentiometer, as I explained, it's going to change the gain. So if we make that larger, it's going to have a lot more gain. Now, there's also the feedback part of the circuit, which has some capacitors and resistors, all, in series and parallel here. And changing that can have some effect too. That can change the basically the frequencies and how much gain it's going to have and some other things like that. First of all, let's start with a different potentiometer and see what happens. Now, keep in mind, I have the gain all the way up right now just to really exaggerate any sort of setting that's going to happen in this circuit. Okay, I have a 1 mega ohm potentiometer here instead of the 100K. So this is a much bigger potentiometer. It's going to give it a lot more gain in one way, but also a lot less gain in the other way. Let's start with it all the way down. Let's turn it on first. So due to the way it's set up with this second op amp, because it is controlling gain in the second op amp, it's really taken away a lot of signal with all of that resistance there. Let's turn it up a bit. So even half, it's still not much. So once we get up almost all the way, and this is a linear pot here, so we can do some things with taper to make it work a little bit better, but we really have to turn the pot all the way up, or almost all the way up, to really get to that point where we have a lot more gain. Let's go ahead and turn it all the way up. So I'll explain more in a little bit, but you're hearing a lot of clean signal in there. And it's really just due to the way the diodes are set up in this particular type of gain stage. It's allowing some clean signal to come through. Almost, I know some people hear the same sort of sound on a tube screamer. It's not a tube screamer, but you're still kind of getting that clean signal on this particular type of circuit with the way it's set up, sort of like you would on the gain section of a tube screamer, even though they're completely two different types of op amps. Now, one thing that Analog Man did on this is, because you could give it a lot more gain, you can clip it differently. So you can add diodes in different places and make it clip much more, kind of like a distortion in a way. It's another thing we did on the Pantheon. Whenever we came out the Pantheon, we allowed you to have more gain and also clip it several different ways, clip the signal several different ways. So you get the soft clipping. You could also get a much harder, more distorted tone. So from this particular potentiometer, let's go to the resistor and capacitor network that's going to kind of help shape the frequencies and so the amount of gain that's in the circuit. I'm going to switch back to the original potentiometer and let's see what we have. Okay, so what this little area is here is the resistors and capacitors that sort of form how much gain is going to, this first stage is going to have, and what frequency is going to be affected. So what we can do is just kind of give it a, if we sort of simplify it a little bit, kind of do the frequency range that the tube screamer is going to do, but just give it a lot more gain. You can see what we can do just by changing this area. So first of all, let's go to stock, and then I'll flip it over to the modification. I have it on a switch right now, just temporarily. So stock. Now we're going to add a lot of gain to it. So that's just one section that we can change, giving it a lot more gain, just a handful of resistors and capacitors. So let's go to the next section. This is part of the inverting op amp stage. There's a couple of resistors that's going to limit how much gain it's going to have. And I think it might be fun to kind of maybe swap in a potentiometer. Potentiometer is going to allow us to change that resistance quite dramatically just on the pot, because that's kind of what potentiometers do. And so we can see what those resistors are controlling in the circuit itself. First of all, let's start at, I'm going to start actually in the op amp, in between the input pins of the op amp itself, because we already know whenever we change the resistance before it, what happens? You get a lot less gain. That's why the larger potentiometer dropped all kinds of volume, because you lost a lot of gain. It was cutting some signal there. So let's go inside this op amp and actually increase the resistance, and we'll decrease it as well. Stock is a 220K. Okay, here we go. I'm going to start out with the resistance down fairly low. Gain is up on the circuit. It's up all the way, or what would normally be the gain potentiometer. Okay, now there's a resistor that's going from the diodes, because we have soft clipping diodes in here, and this 6.8K resistor that's kind of connecting the diodes to the other input pin. This resistor is what's kind of giving us that clean signal. So it's not giving it to us, but it's allowing some of that clean signal to come through. So what we could do with this type of stage is just kind of pinch that bridge off. Just get rid of that resistor and jumper it, so to speak, or we can make it bigger and get even more of a more clean signal. So let's experiment with that. I'm going to go back to my 220K in the gain section here, just so we can experiment with the diodes. Here's the potentiometer I'm using. I'm putting it in place of that 6.8K. So instead of 6.8 thousand ohms, we can go from 0 ohms, well, theoretically, all the way to about 100,000 ohms. So let's start with it all the way down. This is going to be the least amount of clean signal that we can get into it. Again, gain is all the way up. Now let's turn this up all the way and see what happens. Let's go ahead and start all the way down. So you can hear it got more compressed. It did clip more, but you also got more compression in there just by making that one resistor smaller. So I have other videos that talk about changing diodes. I'll let you check those out rather than go through all the different types of diodes we can use here. We should probably know by now that if you change the diodes, you're going to also change the clipping structure as well. Understanding that, let's change some other things. There's a 1K, when we're exiting this op amp, there's a 1K there. We can then take diodes from there to, we'll have to take it to half voltage. Can't go to ground here, so we need to go to a voltage reference, which is 4.5 volts with the way this particular circuit is set up. And then we can clip the circuit there. Again, this is another trick like the King of Tone does, the Pantheon does it this way as well. When the switches will kind of add in these diodes there. Okay, so I have yet the same switch that I'm going to use here. That's just, it's just taking these diodes from 1K to this voltage reference. So I still have the soft clipping diodes in there, and I'm just adding these diodes in after that to kind of hard clip it a little bit more. So again, let's start with it off. I'll flip the switch and it'll have both sets. Off. Turn it on. So as we can see, more compression, more clipping, but still yet more compression. So these diodes are going to kind of contribute to more of a type of compression. Now, please don't misunderstand. I don't mean this is like putting a compressor pedal with the circuit. It is still compression, but it's a different kind of compression, so to speak. It's not like having a compressor pedal on, but it is technically still compressing the circuit. All right, so that's that. Let me pull out this 6.8K so you can see when there is no soft clipping, what happens whenever you just have the hard clipping. So an interesting thing to think about right here is with it set up this way, now we kind of have roughly the first two stages of what would be like the governor, a million other pedals that have been based on this, from our Plextortions to Sir Riot to I think what's the MI Audio Crunch Box. I think even like the Shredmaster. I mean, they're all kind of using these little Lego pieces, so to speak, of the circuit in order to create, a tone. Now, there's other things coming after this to make it a different circuit in the other pedals I just mentioned. But still, like these are two building blocks that are used in this way to kind of do what they do. So let me put that 6.8K back in and we'll fiddle around with the tone controls. Almost done here. Okay, we're now back to the stock circuit here. Let's mess with the tone control again. Let's go with the highs all the way down. So what happens if we put a different potentiometer in here? Well, we change the tone circuit completely. So let's take a look at it. All right, here's our new tone pot. I went from a 25K to a 100K. So let's see what that does. So as you can see, there is a lot more highs being removed. We could actually do something sort of similar if we keep the same pot, but just make the capacitor bigger there. So let's check that out. All right, we're going from a 0.01 microfarad to a much larger capacitor, a 1 microfarad. I'm gonna turn the tone pot around 11 o'clock or so just to really make sure there's a lot of resistance there. If I turn it all the way up, you're not gonna hear a whole lot. Here's stock. Modified, let's throw the bigger cap in. It's rolled all the way down. Go back to stock. And let's throw the big cap in there with the tone control all the way down. So again, this is a much larger capacitor. We can change this capacitor to really get a little bit more of what we want, but it is yet another change that we can do here. From here, the Pantheon has this, and also the King of Tone. Rather than a fixed resistor in a capacitor, we're actually using a fixed resistor, a capacitor, and a variable resistor to kind of create a presence control. And it's basically kind of like two of these potentiometers, one right after the other. Not exactly, but that's kind of what's going on, is two different types of high filtering controls, one right after the other. Now I have a 100K pot in place of this 6.8K resistor. So this is not only going to change the highs, this is also going to change, well, a lot of stuff from impedance on the output to how much signal you're going to be able to really send to the output, because we're changing all this stuff, resistance and everything else, before it gets to the volume pot. And so they all interact together. I've got this presence control up quite a bit. I still have the tone control up just a bit past noon. So here's what we have here. So let me roll this presence control down. So this 6.8K resistor, again, making it larger, removes more highs there. Now we're back to stock. So what happens if we make the 0.01 microfarad capacitor that's going to ground? After that, from that 6.8K, what happens if we make that bigger? Again, less highs. Let's try it. Let's put this big 1 microfarad capacitor right in its place. Gets rid of pretty much almost everything except some very low end. All right, and then finally, we have the output capacitor. It's a 1 microfarad, I believe, 0.1 microfarad, sorry. All right, here is the stock 0.1 microfarad on the very output. Let's add a 1 microfarad to it. Not a whole lot of difference here, not to the year anyways. So what happens if we make it a lot smaller? Let's see. I'm going from a 0.0022 microfarad to a 1 microfarad. So here we are, stock. So it's going to take away base whenever the capacitor is smaller at a certain point. Now there is a point like we can see from 0.1 to 1, not much of a difference, but we get too low and we start taking away base. So there you go. That's basically what you have whenever you're changing all the different parts of the circuit. That's what happens whenever you're fiddling around with them. Hopefully that gives you some ideas of things to change. I'll include a schematic in the description in case you just want to see a schematic of the Bluesbreaker, or you're welcome to Google for one yourself. They're all over the place. And you can kind of see what we're doing here. And hope you liked the video. Love to hear your comments. If you like more of these, a little bit more techy, not super like no one's going to be an engineer after watching this. But hope you kind of like this video and let me know if you do. Thanks for watching. We'll see you next time.